Hello there. In this video, I'm going to discuss about cross multiplication method of solving two equations involving three variables. Here, I have considered two equations where a, b, c, and e, f, g are the real numbers and x, y, z are the variables involved here. So, solving these two equations using cross multiplication method, first of all, we just list out the coefficient of each of the equation. Here, I have listed the coefficient of equation first. So, coefficient of x is a, y is b, and z is c. And I'm repeating the coefficient of x and y again. Similarly, the coefficient of second equations are e, f, g, and I have repeated the coefficient of x and y. Now, ignoring this a and e, ignoring the coefficient of x and y, just we write here x just above bc, we write here y just above ca, and we write here z just above av. So, and I have drawn here the arrows from up to down and down to up. You can see the arrows we have to draw like this. And remember one thing, whenever you go downwards, you remember you just think of positive sign, and whenever you go from down to upwards, you just think of negative sign. So cross multiplication method, by cross multiplication method, if we solve these two equations, then we get x over, so here see the arrow here, x over bg minus fc. Why minus? Because it has, the arrow is going up. All right, so similarly equals to y over, now you can easily say ce minus ga, and z equals to z over AF minus EV. So in this way, we can calculate the values of X, Y, and Z. But in many cases, we have to consider K as a constant of these ratios. So whenever these ratios are equals to K, then we get the value of X as K times this denominator, Y equals to K times the denominator of Y, and Z equals to K times the denominator of Z. So this is the theory part, and this is mostly used in the topic direction cosines and plane in grade 12. So for example, I'll be solving one example for you right here. So these are the two equations where element are the direction cosines of a line. So using cross multiplication method, I'll be listing here the coefficient first. So coefficient of L is 2, M is 2, and N is minus 1, and repeating the first two coefficient, that is 2 and M. Similarly, I'm listing out the coefficient of second equation. What are they? Yes, coefficient of L is 1 and M is 2 and N is 0, and I'm repeating the first two coefficient again, 1 and 2. So here is 2, it's by mistake, it's 2. All right, so here, now ignoring this first one, so writing L just above 2n minus 1, and taking this 2 as M, and taking this last 2 as N. So using cross multiplication method, what we can get is, just you don't forget to make the arrows, it's just for your comfort. You can do directly also. So whenever you just go down, remember the positive sign, and whenever you just go, remember the negative sign. So what shall I write here? L upon 2 times 0, 0 minus from that formula. So 2 times minus 1, minus 2 equals to M over minus 1 times 1, minus 1, minus from formula 0 times 2, minus 0 equals to N over 2 times 2, 4 minus automatically, and 1 multiplied by 2 equals to 2. So this equals to L upon 2 equals to M over minus 1, and N over 4 minus 2 equals to 2. So up to here, I have discussed over here, isn't it? So this is the case of direction cosine. So from the definition of direction cosine, what we know is that L upon 2 equals to M upon minus 1 equals to N upon 2. So I can write like this, over under root L square plus M square plus N square, isn't it? So over, what will be in the denominator? 2 square plus minus 1 square plus 2 whole square, isn't it? So this ratio becomes, what is L square plus M square plus N square? We have already written this as 1. So under root of 1 over under root. So 2 to the 4, 8 plus 1, 9. So under root of 9, this means 1 over 3. So this finally implies L upon 2 equals to M upon minus 1 equals to N upon 2 equals to 1 upon 3. So equating these ratios, we get the value of L as L equals to 2 over 3, M equals to minus 1 over 3, and N equals to 2 over 3. In this way, we solve this equation, these two equations having three variables and only two equations. Thank you.